guys, if you find this video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, today we will be focusing on domain, range and graph of tan x and tan inverse x, and for that let's have an unit circle whose coordinate at 0, pi by 2, pi and 3 pi by 2 are 1 0 0 1, minus 1 0 and 0 minus 1 respectively. And we also know that tan x is equal sin x over cos x. So tan at 0 will be sin 0 degree over cos 0 degree, and sin 0 is 0. So 0 over and cos 0 is 1, so 0 over 1 is 0. Similarly, tan pi is equal sin pi over cos pi, and sin pi is 0, so 0 over cos pi is minus 1, so 0 over minus 1 is 0 again. So for tan pi and tan 0, value will be 0. Now tan pi by 2 will be sin pi by 2 over cos pi by 2, where sin pi by 2 is 1. So 1 over cos pi by 2 is 0, so 1 over 0, and we know that 1 over 0 is not defined. So at pi by 2 or 90 degree, tan theta is not defined. But when x tends to pi by 2, then the function fx is equal tan x, then fx goes towards plus infinity. So when x tends to pi by 2, fx goes towards plus infinity. But at pi by 2, tan is not defined. Now similarly for 3 pi by 2, tan 3 pi by 2 will be sin 3 pi by 2 by cos 3 pi by 2, and sin 3 pi by 2 is minus 1. So minus 1 over cos 3 pi by 2 is 0, so minus 1 over 0. Again, this is not defined. So at 3 pi by 2, function is not defined. But when x tends to minus pi by 2, then the function fx goes towards minus infinity. So when x tends to minus pi by 2, fx goes towards minus infinity. But at 3 pi by 2, tan x is not defined. So now let's find out the domain and range of the function fx is equals to tan x. So for the domain, as we already know that at pi by 2 and 3 pi by 2, function is not defined. Similarly, function will not be defined at 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2 and so on. So therefore domain x cannot be pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 and so on, or we can say that x cannot be 2n plus 1 times pi by 2. Now for the range, at 0, tan is 0, at pi tan is 0, and when x is approaching towards pi by 2, then fx is approaching towards plus infinity, and when x is approaching towards minus pi by 2, then fx is approaching towards minus infinity. So out of these 3 or 4 values, minus infinity is the minimum value and plus infinity is the maximum value. So the range of the function will be from minus infinity to plus infinity. So the range is from minus infinity to plus infinity. Now let's graph fx is equals to tan x, whose domain is x cannot be equal to 2n plus 1 times pi by 2, and range is from minus infinity to plus infinity. So since x cannot be equal to 2n plus 1 pi by 2, so we will have asymptote at pi by 2, 3 pi by 2, 5 pi by 2, and so on. Similarly, on the negative side, at minus pi by 2, minus 3 pi by 2, minus 5 pi by 2, and so on. Now we already know that when x approaches to pi by 2, fx approaches to plus infinity. When x approaches to minus pi by 2, fx approaches to minus infinity. And at 0, tan is 0. Similarly, at pi, tan is 0. So tan will be 0 at 0, pi, 2 pi, 3 pi, 4 pi, 6 pi, and so on. So let's graph it. So as x approaches towards pi by 2, fx approaches towards infinity, and similarly when x approaches towards minus pi by 2, fx approaches towards minus infinity. Similarly, we can graph it for the intervals pi by 2 to 3 pi by 2, 3 pi by 2 to 5 pi by 2, and similarly on the other side, that is from minus pi by 2 to minus 3 pi by 2, and so on, where fx will be 0 at 0 pi, 2 pi, 3 pi, minus 2 pi, minus 3 pi, and so on. So this is how we graph tan x. Now for the inverse function, we know that a function can have an inverse if and only if it passes the horizontal line test. So let's do the horizontal line test. So as we can see that horizontal line is intersecting at more than one point, so it fails the horizontal line test. So this function will not have an inverse unless we restrict or reduce the domain of this function so that within that interval it passes the horizontal line test. So let's first take the interval between minus 5 pi by 2 to minus 3 pi by 2 and see if it passes the horizontal line test, and we can see that it intersects only at one point, so it will pass the test. Similarly, we can say the same for the intervals from minus 3 pi by 2 to minus pi by 2, from minus pi by 2 to plus pi by 2, pi by 2 to 3 pi by 2, and 3 pi by 2 to 5 pi by 2, and so on. So among these intervals, we can take any intervals, but for the principal value, we take the interval from minus pi by 2 to plus pi by 2. So this is the reduced domain for a function tan x to have an inverse. So function fx is equals to tan x has domain as x cannot be equal to 2n plus 1 times pi by 2, and range is from minus infinity to plus infinity. Now let's find out the domain and range for the function fx is equals to tan inverse x. So domain and range. So the range for the function fx is equals to tan x will be the domain for the tan inverse x, that is minus infinity to plus infinity, and the reduced domain or the principal value, that is from minus pi by 2 to plus pi by 2, will be the range for tan inverse x. So the range will be from minus pi by 2 to plus pi by 2. Now let's plot function fx is equals to tan inverse x, whose domain is from minus infinity to plus infinity and range is from minus pi by 2 to plus pi by 2. Also, if function fx is equals to tan x, or we can write it as y is equals to tan x, then the inverse of this function will be just switch x and y, and we will get x is equals to tan y. So the roles of x and y will get interchanged. So the domain for tan inverse x is from minus infinity to plus infinity, and the range is between minus pi by 2 to plus pi by 2. So we will have horizontal asymptotes at pi by 2, 3 pi by 2, 5 pi by 2, minus pi by 2, minus 3 pi by 2, minus 5 pi by 2, and so on. And we will have x is equals to 0 at 0 pi, 2 pi, 3 pi, minus pi, minus 2 pi, and so on. So this time, when fx approaches to pi by 2, x approaches towards plus infinity, and when fx approaches towards minus pi by 2, x approaches towards minus infinity. And we can say the same for the other intervals too. So the function fx is equals to tan inverse x will pass the horizontal line test between the range minus pi by 2 to plus pi by 2, and that is the principal value of this function. So this is how we graph tan inverse x. Now here is the quick trick to graph inverse of any function. Take a graph of a function, rotate it 90-degree counterclockwise, and then flip it, and you will get the inverse of graph of inverse of that function.